Good. So one of the goals of this presentation was not to be the old rehash of the model, view model, and a view. I'm trying to kind of talk through that a little more lightly, and then try to talk about how you build advanced applications with MVVM. Maybe figuring out how you get around some of the problems that you often encounter, and also provide you all with some tools that can help you get around those problems. But of course, there will be an introduction about what it actually is, because I'm sure there are some people in here who don't know what it is. So I want to kind of talk about MVVM and how I kind of came into learning about it. So for those of us who remember the days of building web applications, you probably remember the days of building that giant JavaScript file that had about 1,000 lines in it. It was packed full of jQuery, and it handled everything your application did on the front end. Who wants to raise their hand and admit to it? There's more people out there than that, I know that. Anyway, so I kind of started to find this pattern of MVVM through what I call the fourth tier. And that fourth tier was more or less interaction. We're all aware of the three tiers, which is a view, business logic, and data access. But I would submit in a web application, there's often a fourth layer that's often providing the interactivity of the application. And that's kind of where you started to see this problem emerge in the old days of programming with a lot of JavaScript being written. We have since kind of come full circle on that with the advent of MV star, which is actually outside the topic of this talk. But the origin of MVVM is actually not from the web. It's actually born from John Grossman. He was a WPF architect at Microsoft on the Xamarin team. Previous to MVVM, a lot of people used what we call Model View Presenter, or MVP. And this new MVVM model was a variation on that pattern. But there was a very different kind of flavor to it. Before now, binding has always existed in .NET since 2.0. There's a data binding class you could use in ASP.NET Web Forms as far back as you can remember. But the difference with MVVM was actually declarative binding. The idea of the view dictating what it was that you want that it needed to bind to actually work. And that was the big movement with MVVM. So to kind of, let's walk through what MVVM actually kind of is first, then we'll kind of get into it. So we have the view. In the separation of concerns, the view is responsible for how it presents content to the user, be it HTML, be it a GUI, be it even a console application to a degree. The view model is a class-based representation of the view. That means inputs are simply properties or descriptions of that particular class. Behaviors or events are actually actions, or in MVVM terminology, commands. So by simplifying this definition, we get this view model that abstracts away the functionality of the view into a more, I guess, condensed form. And there's a lot of advantages to doing this. But the biggest one to me is testing. Who in here has ever actually UI tested their apps? How did you do it? Well, sometimes talk to some framework side of me. Come on. Karma. So a lot of people who actually do UI testing, they tend to load up the UI and they click and they have a little mouse go over, they click different parts of the application. With MVVM, when it's done properly, you don't even have to do that. You test the view model because your view model is representative of all the UI functionality on that page. And furthermore, if you combine it with dependency injection, you can then mock behaviors within your view model. It's a very powerful way to program. Okay, so I've kind of explained that to you. Now I want to go through the three core concepts of MVVM. The first concept is this idea of data binding. And this is one of the most central points to MVVM because it gives its power. I just talked through an example of using this application for testing. The reason that that can be done is the view model has no idea what view it's talking to. As an MVC, model view controller, the views in MVVM are designed to be passive. Ideally, they can hook up with whatever view that you so desire. The data binding is not a contract. It is a suggestion, more or less. If a view specifies a binding that doesn't exist, it just doesn't bind. If it's there, it binds. Obviously, in the reverse case, if you try to use a property that's not on the view, you're probably going to get a no reference exception. But the point here is that there is no direct connection between the view and the view model. And this is why this is so important. We're talking really at the end of the day about separation of concerns. What is important to the view versus what is important to the interaction held by the view model. Now, in .NET, this is primarily driven by this property change event. I notify property changed if you're looking for the interface. The antithesis of this particular interface is that it gives the view a way to respond and the view model a way to notify when something changes. This means, as in this particular case here, this code, I can specify a property that is also duplicated in the view model itself, and automatically, when the user types a character, username property is updated. If this class were to change the value of username, it would appear in the text box automatically. The power of this is that it separates that view from the view model, which is what we're really after. Because again, one of the great advantages to taking this approach is the ability to test the view model, which is really what we're after. But also, it gives us a way to separate, to organize our code in a way that makes sense. Because previous to this, you'd stuff a lot of this in a JavaScript file or in a code behind file, maybe in some arbitrary class that you're holding in memory somewhere. But what this does is it kind of decouples that entire process and kind of allows you to organize your code in a much better way. So now the second core concept is commands. In general, when you're talking about MVVM, you will never use events. It's not directly. Because again, there are cases where events don't make sense. And one of the advantages to MVVM is going to be your ability to target multiple view models, or in some cases, multiple platforms, as is in the case of Xamarin. So with commands, you're able to take a very abstract way to fire off an event. And this is a very simple concept because it's based on a very well-defined computer science pattern known as the command pattern. Has anybody heard of the command pattern before? Studied it? One of my favorite patterns, why I like it so much. So the idea with the command pattern, though, is we're going to expose a command on the view model. A command that can be carried out, but also has the ability through a can execute to actually not be carried out if conditions are not met. This is an optional, of course. You can have the command always fire. Now I want to show an example of what this could look like using a simple XAML example. So I'm going to fire this up. Oh, I want that horn. I want this to duplicate. Okay. Say PowerPoint. You always do that. Okay. So what I've got here is that this is a very simplistic example. This is written without any kind of frameworks, straight code through WPF. So let's go ahead. So what I'm going to do here is, you notice I can't click on anything. So let's type in Jason Farrell and just 32 and click me. And that pops up, 32 years old. I disable, enable it. So I want to show you guys the code that actually drives this application. So first thing we'll look at is the view itself. Okay. So we'll look at a couple things here. Now, as I said before, generally you have these commands, and that is actually what drives this process. So there were two buttons on that form. First one was the ability to actually click the application and have to say hello. Second one was this toggling of the enable. What you will not find anywhere in this example is code in the code behind. Not a single line, except for the initialized component, which is necessary. All the logic is actually carried forth inside here. So again, as we talked about, I'm binding first name to first name, last name to last name. And even though what the text field is going to actually take is going to be a string, you'll notice that the age is bound as an int. So not only are we able to bind this, but we're also able to get type conversion all automatically. So if I go back now and decide my actual age is ABC, anybody got to guess what I'm actually going to get?
Should get error.
Error? Anybody else? Exception? Anybody else? Virus. Okay. We're getting worse and worse here. All right, let's see what happens. Apparently, I'm 32 years old still. That's not right.
Yeah, refresh it, most likely.
Probably.
Refresh it.
That's really weird because it's actually supposed to be 0.
There you go. So
Well, that's the starting state. Oops. 0. Because what is the default value of an int in .NET? 0. So it gives you kind of a way to, if you don't want to do the type conversion, you can check and say, because nobody's 0 years old, at least they shouldn't be. Maybe. I had a snarky remark for somebody, but I'm not going to say it. Anyway, so what is really driving this entire process here, including the enabling, are these bindings. So this is in XAML, so this is a little different than what we're going to look at a little bit later. But you see, all I've gotten here are these bindings. And again, this is the view declaring what it wants. It's not the view telling us anything, just that, hey, whether I'm enabled or not is based on this particular value, if it exists, and it could not exist. So the command here, though, we want to get at is this general command. So commands in XAML are based upon the iCommand class. And this is a very rudimentary implementation of this. So you see we have the can execute, which allows us to pass a parameter and then check. Okay, this is not in the right state, I can't execute. So you see, even if I go back to here, let's play with this example a little bit, just so we can get some fun here. So if I do this, and yeah. Okay, so let's have a look. What will happen when I hit enable? Nothing? Anybody else? No? So actually, Dave, I think you were kind of right. I kind of tricked you a little bit. Now what will happen? He says nothing still. Anybody else? Come on, the PPs ain't that good. You guys aren't all asleep yet. I'll turn 33. Wow, only the button's enabled. Why is the button enabled? Let's go look at the XAML really quick. I don't have any binding on the enable state. Anybody have any guesses why the button's enabled? Come on. Yeah, you got it. Because actually, with a button and a command, you're disabling the button based on the can execute. So in this particular case, we're still actually binding to it. So whether or not that value is true or false is what dictates whether the button's enabled or not the is enabled flag. You could do both if you wanted to, but you actually don't need to in XAML. Anyway, let's move on to the next aspect to this. So the final core foundation is the view model itself. Now we've already talked a little bit about view model. The big thing with the view model is giving you the ability to organize your code inside of it and to support that interactive element in a way that makes sense. The best thing when when you start combining view models with dependency injections, do autofact or a custom library, you can quickly bring services over that can help you interact with the platform much better. You saw me using the dialog, for example, in that last example. Let's see here. So what I'm going to do next, though, is I want to show you an example using a framework instead of just straight code. So when I first got started with MVVM, the framework that I learned it from was actually called Caliburn Micro. Caliburn Micro is a very lightweight framework, and it really does, it's designed specifically for .NET. So you're not going to be able to apply this outside of the .NET space, but it's designed for Windows Phone, Windows 8, Windows 10 now, Windows RT, that whole thing. So let's go ahead and open it up. Okay. So we're going to run this now. Now this is going to be a very similar example, but we're going to use this example going forward a little bit more. So similarly, now I want to see, so if I do this, hello Jason Farrell. Now if we actually look at how this takes advantage of Caliburn, it's a bit different. So the first thing you'll take notice of is now we're applying a convention in how we develop MVVM apps. You'll find this convention is pretty consistent across most frameworks and ways we do this. You have a view here and view models. Notice the name. The names are done so in a very explicit manner. Bindable properties view, bindable properties view model. The reason that's done is it's very common in MVVM for the view model to handle navigation. So what you saw earlier was one screen, no navigation, very basic. In this case, we're going to go to 2 different screens, and we have to kind of govern how that happens. We can do it a number of different ways. We could reach into Windows 8 and actually invoke the navigation service if we wanted to. But that's not a very good approach because that's not how you do MVVM. The core emphasis of MVVM is everything is done in the view model, not in the view or in that specific area. So if I actually go into to the main view model here, you notice I have this iNavigation service. This is provided to me by Caliburn Micro, and it gives me methods to interact with the Windows 8 backstack to kind of move pages back and forth. And you can see right here how we navigate. And one of the things that should stick out to you here is we never reference the view. But yet, if I run this, it knows. Oh, no, it didn't die. And it knows how to get there. So, and the reason that this works is we go back to this idea of convention. What is happening is I am telling Caliburn to stop the application. Back to stop. And when I tell it to stop, when I give it the view model, what it does is it takes the class name, strips off the model, and tries to find the view. And it tries to find the view under the views folder. And you'll see this convention used consistently in most MVVM frameworks, because that's how it makes sense. It makes sense to do it that way. Okay, let's move on. So let's go ahead and kind of jump out of the whole introductory stuff. Why do we use MVVM? Why do I use it? Well, in my line of work at Western Monroe, we deal with a lot of platforms, and mobile in particular. But I also like the idea of that separation, that presentation logic from my presentation. It gives me that clean separation. It's the same reason that we've all started using Angular, or we should be using frameworks like Angular, Durando, and these other frameworks that provide that level of organization for us to separate this large amount of code. We're writing a lot of applications today that are highly interactive, and they require more and more code to work properly. And how we organize that code is very critical. But there's a danger with MVVM. It comes from John Grossman himself. The overhead of implementing MVVM is overkill for simple UI operations. What does that mean? It means if your application is simple, don't use MVVM. You're going to kill yourself and you can get no benefit out of it. You have to always think about why you're doing something before you do it. Because you look at the application that I wrote, even the simple one. How many lines of code did I have to write to get that thing to say, hello, Jason, you are how old? Was that really an efficient use? No, it was not. So we have to constantly look at what we use MVVM for. In some cases, MVVM just doesn't make sense. But when I do use MVVM, I approach it with a certain amount of understanding. Let me be clear. Implementing MVVM, understanding what MVVM is easy. Implementing it properly takes a lot of time and a lot of discipline because you're going to be writing a lot of extra code in many cases. And the idea with MVVM is you're going to write it now to save yourself down the road. So you have to be careful and pick your places very carefully. Because what you're doing is you're separating all your code into more of an abstract fashion. And in doing so, you're able to extend that out. Now, I won't lie, most commonly, your view models are only ever going to apply to one view. It's nice to think about them applying to more than one view, but the reality is I really have ever seen that happen unless you're talking about multiple platforms. So when you start talking about Windows 8, it's a great way to maybe manage a lot of code in a complex application. But if you start thinking to yourself, I'm going to use this view model to modify all my entities like a person or an address, it's probably not going to happen unless you write a lot of extra code. So with that in mind, I do want to talk about some of the tools that I use in MVVM that kind of helps operations be more simple. First of those is a converter. So this idea of a converter is centered to MVVM because it actually allows the view to dictate how it interprets a value. Now, the most common use of a converter, in my opinion, why they exist, is for some reason when Microsoft wrote XAML, the visibility was done so as an enumeration and not a Boolean. We've had to deal with that before. So they wrote, my idea was they did this so you had to write a converter to actually hide and show elements, which we continue to do today. But the real reason that these exist is a lot more higher level than that. There are simply cases where you're going to provide values from your view model that just don't make sense or have special meaning to the view. And the view is the one who's dictating what that special meaning is. This goes back to separation of concerns. What is a concern to the view versus the view model? If you think they're both existing in the presentation there, you have to be very careful walking this line. I see a lot of people create read-only properties to expose that visibility enumeration, for example. And while that does work, it's not extensible. You choose to support another platform. What do you do if they don't support that enumeration? So in many ways, I consider this anti-pattern. It's not a concern. Anything that is specific to the view is not of a concern to the view model. The view model's only task is to carry out operations and provide data to the view model. Okay? So let's look at what a converter actually looks like. So we're going to go back to our example. Oh, not that one. So for those of you who like visibility, so this is actually using a converter. All these are. If I go back, these are all just. So what I've done here, if you look at the converter view model, is I have created a list of random numbers, just 7 of them, between 0 and 20. All I do is create the list of numbers. Okay? That's it. Supposes the list of numbers. But what I do have is this converter. So what happens is, as this thing receives values coming from the view model, depending on the modulus from 3, it's a different color. So that's how you get that rotating color aspect. Now the code to actually carry this out is again located in the view. So the view is saying to the view model, I will handle this in the way that I see fit. Right? So converters is one critical way that we take a value in the view model and then choose how we display it. This could be anything. It could be a price. It could be a total. Maybe if your total is negative, you want to display it as red. So how would you do that? If you're displaying a list of prices, negative and positive, what would be the best way without a converter to actually show the right color? Right. Which would be the anti-pattern. Exactly. I mean, yeah, it's 100% right. And that's why converters exist, to give us that flexibility so that you're not creating now two properties. Because otherwise you'd have a property for the actual total and a property for the color for that total, which you probably don't want. It's more code that you probably want. So go back to here. Now the next example I want to show you guys is one of my favorites. So just because a property exists does not mean it's bindable. So the reason I talk about this is you're going to have a lot of controls. List view, maps, grids. Just because you have an item source property does not mean it's bindable. And that may seem counterintuitive. But actually, only certain properties defined a certain way can be bound to. And this is a very critical aspect inside of MVVM. So you have to sometimes create your own properties. Now, in many cases, the controls provided by Microsoft already support this. So you won't have to worry about it too much unless you start to step outside of the box. In XAML, we refer to these as dependency properties. In Xamarin, they're referred to as bindable properties. The idea is you're going to define a static property that actually will act like an instance property. You define 3 core values for some other stuff, but you define who has the variable, what its type is, and most importantly, what happens when it changes. And that's the most important aspect of this. So I'm going to show you guys how to create your own property on a control that links to an observable collection, and as these are added, will automatically update a graph. Before I do that, there are 2 primary ways that you achieve this effect. The most desirable way is through inheritance. The second way is encapsulation. You wrap the object. You have to do this sometimes for classes that are sealed, because you just cannot inherit from them. So, without further ado, let's go ahead and look at our example. So, I'll trust the example yet again. So, we'll go to Bio Properties. So we have here a map of the lovely city of Chicago. Oh, there you go. All right, somebody else give me a place. Has to be a name, though. Anybody? What?
United Center.
Bingo. Anybody else? Come on.
University of Chicago.
University of Chicago. Maybe type a lot. Boom. Anybody else?
Aeon Center.
Aeon. Oh, where am I at right now? I have no idea. This is giving you how much this will work on that. It does. Woohoo! It's on there actually. Anybody else?
Sears Field.
I don't recognize Sears Tower.
Martel.
Okay, is there an actual? Oh, uh-oh. We are no longer. Okay. Let's try Sears. Bing, you fail! All right, so now we actually zoom out. You'll see that you're seeing all the points on there. So what I'm doing is that all these points are actually being maintained on this. But I'll tell you right now, the Bing map does not support any kind of bindable property. So let's look at how this was done. Now, I won't warn you, this is more of a complicated example, but I think this kind of gets across the point better of what you can do with bindable properties. So let's look at our view model first. So I'm going to close all these guys down and open up our guy here. So we have several services in here, but the most important one is this geocode service. So what I'm actually doing is reverse geocoding the name, getting the lat long, and dropping a point on the map. Pretty simple stuff. So I'm not going to get into how that's all done. But see, this is kind of what I mean by dependency injection. So these dependencies all get injected into here and assigned as properties. So I can kind of use them as I want. I could even mock them if I saw fit. But down here is where the magic happens. That's it. So you can grab a location by querying the geocode service. You drop the location on this locations collection, which is an observable collection here. Now, something to note here. We'll take one step further before I do that. So if I go to the bindable properties XAML page here, bindable map. Binding locations mode one way. Now, let's go ahead and look at that particular property inside of the bindable map control. This is an example of encapsulation. I'm not able to extend the map control, so what I've done is I've created. What I've done is I basically just dropped it inside of user control. So I can bind to the user control, and then the user control will communicate internally to the map itself. This isn't really a break of MVVM because I can now reuse this bindable map control wherever I see fit. And as long as I bind and talk to it the same way, no harm done. Should probably make that private though, whatever. Anyway, and you all can memorize that if you want, the credentials. I don't care. Anyway, so you notice, I want to kind of walk through this really carefully because this is where it gets kind of tricky. So if I go back to here, I'm sorry, wrong one. Not there, I want here. You'll notice that we have this locations property that we're binding to. Okay? But if I go to the actual bindable map, you will notice I have two locations properties. I have locations property, which you do not see, and I have actual locations. So this is what is known as a dependency property in XAML. And this is what almost every single property on modern .NET controls looks like. And the reason they look this way is what supports the binding. Now, so I'll walk you through this very carefully. We're going to register it, locations. So we're saying the property locations on bindable map of type observable collection of map location is a property. And when this property changes, call this, which is located here. Now, for a lovely key, how many times does location change get called if I have 3 points? No. 6? No. There's one person here who should know the answer because I told him it at work today. And he just gave me the answer and it was wrong. I did too.
I might have had my headphones on. I said it at me.
Anybody else got any answers? There you go. Who said that? One time. So only once. Why? Anybody know?
I'm looking at the dependency object, and once you make the dependency one time, call one time, it's dependent. When you set the property, that's one thing.
Correct. I'll give you one too. So, what is the initial starting value of any object in .NET?
No.
No. So when I assign it, what happens? It changes. But if I add stuff to the collection, does it change the object reference? No. So that's why you see this next line here where I am looking at the collection change. You see, I lied a little bit earlier. There are two central interfaces to binding in .NET. I probably changed the most prominent, but also I notify collection changed. Observable collections are able to notify you when they're added to or removed from. And in this case, when they're added to is when we care about them. So you'll find this kind of code in almost every single .NET property that is bindable. Well, with an observable collection, like a list or a grid, this is how they actually do it. So when a new map location is received, I create the ugly push pin you saw. I have no idea why they're using that ugly pad. Set the position of the pin and drop it on the map. Pretty simple. So under the covers, we're still doing this the exact same way. But to any user of this application, all they see is this. And I could add bindable properties for zoom. I could add bindable properties for map type. So you could change it. It's very trivial at that point. But again, you have to, this is what I mean when I talk about writing extra code. And you have to really kind of gauge whether MVVM is going to be valuable for you or not. Okay. The final example I'm going to walk through is actually not going to involve this code base. So let's go ahead and talk through. So So if you think about a view model representing a screen, there is a chance that you might have multiple screens on one screen, or multiple views open at any given time. Maybe you could have an. Maybe you could have one that keeps repeating for everything that they open. How could you possibly keep track and notify these when something else changes? You can't pass a reference to it. It would be a nightmare. That's where the idea of a message bus comes in. And you'll find this concept in MVVM quite frequently because, again, we don't want our view models to be aware of each other or the view. We want separation. We don't want to tie ourselves to any one particular means of communicating. So a message bus, I'm sure a lot of you in here have used them before. You have a central bus that you're basically subscribing to, and as you publish a message out, it receives it, executes the message. No different. So I want to show you, though, there are some interesting use cases with a message bus inside of MVVM. The first one, so what we're going to look at, first, this is kind of how it works for the initiated. Two views. A view model will subscribe to the message bus saying, I am waiting for the person change message. When I get it, I'm gonna execute the person change method. So the other view over here publishes the person change message. This guy says, oh, okay, sends it to you, executes, and does whatever he needs to do. Now, the reason I'm bringing this up is I want to show you guys a demo. So the code you're about to see is actually a stripped-down version of a production application that we are currently writing in West Monroe right now. And what it does is it's a diagnostic tool, but it's using Bluetooth to basically perform diagnostics against industrial equipment. Because the client wants to use both iOS and Android for this process, and we want to use MVVM to make sure that we can share our logic, obviously it's clear Android and iOS do not operate Bluetooth the exact same way. Right? Makes sense? Two completely different APIs, but we want them to be the same. And so we're going to use messaging to kind of circumvent this limitation. So, okay. Now, in this particular example, we're only going to look at the Android side of this. Okay. So, heaven help as this works, because this is what I was having trouble with earlier. It's a cool demo if it actually works. Okay. So, while we wait for, oh wow, that was fast. How it's warning us. Okay. Now, unfortunately, you're not able to emulate Bluetooth on a emulator. What I can show you is this. All done using MVVM. So let me kind of show you guys what's actually happening. So when you're talking about Bluetooth in Android, and this is going to be a little specific, so for those of you who don't do mod mobile, I apologize if this goes a little bit foggy, but in Android, the way that we deal with Bluetooth centers around this concept of a receiver. So as the OS receives events for Bluetooth, it sends out a signal. And your application can then receive that signal and take action. One such action is the device connected, for example. This is where messaging can really come into play. In this case, we're using MVVM cross. We resolve our messenger, again, dependency injection. This is more service location. We use that to publish. So this message could come from iOS or Android, and it would mean the same thing to the view model. If I go to the view model, I'll just pick any view model in here. Should be the temps. Let's see. All right, so not here. Device connected. So right here, there's our subscription. So this example basically is we have two ways of talking to Bluetooth devices, two completely different paradigms, but yet we're able to unify this into a single view model. So bear with me for a moment. I want to talk about something called the bridge pattern, which is this is a technique that is used very heavily in Xamarin, but can also be used in Windows and other .NET applications. So one of the things I would like you guys to take note of is this iSensor Manager here. Okay? So the iSensor Manager is responsible for managing the sensors via Bluetooth. Obviously, the way this communication is done is different between the two platforms. However, to the view model, it's not different. To the view model, it's the same because we've abstracted away the differences to an interface. So what happens is, if I go into, you know what? So this is the Droid Sensor Manager. This class is actually located at the Android level. And it is very specific to Android and Android alone, using Droid Bluetooth device, for example. Can't get much more Android than that. But yet, the view model, which is located in a completely different assembly, is able to say, hey, this class is going to implement this interface, so I can call this method. What this method doesn't matter to me, because it's defined at the platform level. So even though that view model is calling get temperature reading or calling connect here, how it does that is left to the platform. So I use this pattern a lot for dialogues or for really anything, file system operations, network communication, because while these are different, they're the same interface. And that really induces this idea of messaging and a view model being abstracted away from the view. Oh, wow. How does that work? That's fun. So, I apologize if this is a little kind of hard to follow. So, in the end, what's kind of happening here is we're going to have two disparate platforms. They will use messaging at the platform level to say, hey, view model, this happened in the Bluetooth world. The view model will then talk to its Bluetooth API for that platform through an interface. That's kind of the end goal here. This is an example of how MVVM simplifies that coding layer. So while the view model is organizing your interaction, and your interaction can vary depending on what platform you're targeting, your core view model logic is still the same, and the way that it talks to the actual view also the same. Okay, so okay. So what we just talked about was walk through some rudimentary, some concepts. Some of them are very high level advanced, to cut down on the amount of code you may have to write. The idea of using bindable properties to add functionality to controls that didn't previously exist. The idea of using a converter to allow the view to dictate how it handles a particular value. And finally, using messaging to facilitate the communication between multiple view models, whether they be in a central library or in a specific library for that platform. So think to yourself, how can we use these concepts effectively? And the answer is, you've seen me use a lot of frameworks here. I've mentioned Xamarin Micro, and I've mentioned MVVM Cross. There's actually quite a few out there that make a lot of sense. The bottom one, Prism, is actually the one that's used by Microsoft on their research and development teams. Knockout.js is one of my favorites for the web. It's probably the closest among the web frameworks to actual MVVM, whereas Angular and Ember, Backbone use MV Star. Not quite the same thing, but a very similar concept. So the last section we're going to talk about is going to be purely mobile. So I've mentioned MVVM Cross a number of times. And the reason I want to call this out specifically is when you start looking at Xamarin, you start in this idea of targeting mobile platforms. That's when you really start to see MVVM become a really solid design pattern. Because we talked a little bit about how views are passive. And if every platform defines its own view, they can, in theory, link up to the same view model and share that logic. So imagine if you're creating an application that targets Windows Phone, Android, and iOS. What if I told you you could write the view 3 times, one for iOS, for Android, or Windows Phone, but each view simply bound to a view model, and you only had to write that logic 1 time? And West Monroe were able to turn around applications in 3 weeks, as opposed to a month and a half of development. It's a very powerful way to develop applications. So I want to show a very quick example of this using Windows Phone and Android. I just realized that. Well, let's see how fast it goes. Okay, so let's find. Oh, that's fine. Just can't see it. Let's see if PowerPoint does that. Go solid state. Okay, so I'll walk through this really quick. So it's more of the same that I've been using. There's some Farrell, but this is kind of where you're going to start to see the bridge pattern being used. I can disable it, I can re-enable it. Yay. Sure, why not? Go ahead. Oh, I see. Okay. Done. No, I told you to stop. I heard you were stopping. All right. So while this is actually starting up, this is going to take some time because solid state are not the default into the MVVM or this too. It takes time. So are there any questions right now?
We were talking about conventions before and about how in the MVVM model projects usually they're divided by typology of class, so you have views and models. And what I'm seeing in some trends is people now say that another convention would be to separate folders or projects, not just by features. So you put the view and the view model inside that that covers
The same namespace.
Yeah, exactly.
So basically, it's I've not seen that pattern before. That might get kind of
Angular, for example.
So I see. Yeah. So Angular. Oh, this is lovely. So Angular is a bit different in the way that it handles things. So in Angular, you don't really have a prescribed view model. You have the controller. You have this idea of scope, the digest loop. So I know what you're saying, and it's I would say that's very much a web-centric principle. It's because of the way that HTML pages can be laid out. It's not really the same thing, but the thing about Angular is the way that it does that through because you can actually declaratively tell the controller here. When you talk about GUIs and like phones, for example, you don't get quite as much granularity with the view in terms of where your sections are. You can, but it's a lot more work.
So it makes more sense.
Makes more sense on the web versus on a phone or whatever. But yeah, I've seen that in Angular, yes. So anyway. So let's look at these two wonderful applications now. That started up really fast. You guys must be a bunch of lucky people. So now, so what's going on here is I have two applications that do the exact same thing. Two different platforms connected to one view model. So let's walk through what this looks like. And I apologize to the non-mobile folks in here. This is very much a mobile kind of trend concept. So the first thing I want you guys to look at is this core library. So core library is a PCL, portable class library, which means it can function on Android, iOS, Windows Phone, Mac, whatever. It's a joint venture between Microsoft and all these other companies to make .NET work everywhere. Now it defines our view models. In this case, a single one. Okay, we have this dialog service. We have first name, we have last name. We have is enabled. All of these, you can probably guess how they're being used on those two views. We also have the say hello command. Okay. Now, what's interesting here is the dialog service. As you might guess, the way we display a dialog on Android and Windows Phone is totally different. You certainly can't call messagebox.show on Android. We could, just won't do anything, honestly. So here we have underscore dialog service.show alert. Okay? Now, keep in mind that both Android and Windows Phone are both calling into this code. So how do they know which one to use? The answer is in our setup files and through dependency injection. So I've created this class called the Droid Dialog Service, which, if we go into it, it creates the old alert dialog builder and shows the dialog. Okay? So now let's look at the exact same file on the Windows Phone side. Phone dialog service. Messagebox.show. So what's happening here is when I run the application in Android, the previous class gets injected for iDialog service. When I run the Windows Phone version, this class gets injected. To the view model, there's no difference. It's the same interface.
Can you do Apple? Can you do Apple?
I can do Apple, but I don't have Apple. In order to show you the Apple example, I have to have a Mac up here. And she's got the Mac right now. She's got And it was, I don't have the code written for it either. But the idea here again is if we go back and we look at each of the two projects. So if I go to the Droid project, I have an activity called main activity. Main activity, main view model, naming convention. Now, in actuality, in Android, the layouts are actually located here. Come on, open up. I don't want to see them. You can probably look at this and guess what's going on. Is enabled, say hello command, binding all the way up. Now, there's the Windows Phone side. No different. Slightly different syntax. So, using this approach, can anyone guess how long it would take me to write the iOS version of this?
Days, weeks.
Jackson?
25 minutes.
24, but close. No, the idea is once you write your logic one time, you should be able to just share it with all your views. And if you take this approach, which is is tremendously popular in the Xamarin world, and slowly making its way onto like the Windows 8 world, especially when you start talking about universal apps, this paradigm becomes very, very powerful. And this is kind of what MVVM is all about, is that sharing of the views to a central view model, so you've only got to write your code one time. Okay? Now, let's go ahead and down the home stretch. So, some reminders about MVVM. Your views and your view models are passive. They can go with each other however you want. There's no requirement from the binding of the view that something has to exist. There's not even a requirement from the view model, other than the requirements you yourself create. If I have iDialog, if I have a first name up there, and I have no property named first name, and I try to uppercase first name, I'm going to get a no reference exception. That's on me, it's not on the framework. And always strive in MVVM to make sure that the view and the view model are never aware of each other. Because the second you do that, you're coupling yourself. And as we all know, as we program, dependency injection, encapsulation, separation of concern, all of these things are about having us decouple our code from concrete implementation. MVVM is no different. You're decoupling yourself from your own view now. And in a way, it allows you to extend much easier and to reuse that logic over and over again. So I want to close with just some thoughts. I've been doing a lot of programming for a long time, and I've always kind of found that as I move forward, applications get more and more complicated, more and more interactive. And thus the emphasis on being organized in how I program becomes ever more important. Knowing how to organize my code, how to use it, how to structure it, is an essential task in mine and I'm sure everybody else here's daily work. So I look at MVVM as a great pattern which can help achieve these goals if used properly. There's a lot of MVVM out there that is just simply not used properly, and I read on Google a lot of the horror stories. And I'm always amazed. You have to kind of know this going in, that MVVM is very easy to grasp, but it's very difficult to implement properly. And you can very easily shoot yourself in the foot. I'm often, and this is a kind of a side note, a sidebar conversation, a person once asked me what I thought of ASP.NET MVC. And I said, it's great. It makes it easier for me to shoot myself in the foot. And the idea was, as we progress in these patterns, we're given more and more flexibility as developers. But the emphasis is then on us to be disciplined with how we use them. And MVVM in that regard is no different. If you do it right, it can be very rewarding, because you can then turn around another platform in Xamarin in 3 weeks as opposed to a month and a half. I'm not recoding a bunch of stuff. And it's a great feeling when you actually achieve that level of reusability in any code base. So all the examples that I gave, with the exception of the messaging demo, are available at this URL, full code. So bindable properties, the basic command example, that whole application that I showed you with the map points, I'm sure you guys all want to go home and see how much you guys can reverse geocode stuff. That's all available right there. I'll leave that up. So with that, questions, comments, philosophical rebuttals. I'm not done yet.
There's also some questions.
I mean,
Give 'em a hard time.
all right, let's, good questions, get a USB stick. Okay, here's the test. What are the 3 foundations of MVVM? Anybody? What? What are the 3 foundations of MVVM? What?
I know property change.
Nope.
Data binding.
Data binding is 1. Who said that? Who said that? Oh, I should go play for the Bears. My God, I'm doing really well here. I'm out of USB sticks, so last one. Emails, golf clap. That's all I got. Right? That's it. I only had 2 left. So, are there any questions on this stuff, guys? I kind of went through a ton of stuff.
So you didn't show an iOS example. How does MVVM play with the more standard MVC?
It's supposed to be passive, but I've just never seen it done in practice. But, in iOS, and it's more code-centric because the lack of the infrastructure in iOS that you support. These XML type files. Yeah. Very similar to how it is in Xamarin. In Xamarin, you've got the XML front end, you have the code behind. It's really only in Android you have true separation. You have the activity, and then you've got the XML layout is often meta layer.
You mentioned that MVVM cross was really good at making that separation on the platform. How is Caliburn seeing that?
So Caliburn only operates in .NET, and it's very interesting. I use Caliburn to learn MVVM, and now looking back, I see that it doesn't do MVVM quite as well as the MVVM cross does. For example, Caliburn doesn't really operate with commands. It lets you attach messages within the example structure itself to call event handlers. One of the things that I try to do in MVVM is have my command method be private. The idea is I don't want you to ever be able to call that method from outside of ViewModel. It's private. But in Caliburn, you don't do that. You actually expose the actual method, and then it's called on the click. So it's kind of doing some magic behind the scenes to wire up the event for you. Is your question?
Arguments you present, you show.
So the server communication would be a responsibility of the service attached to the UL. I always tend to look at MVVM more as a client-based pattern, not a server-side pattern. Generally, I wouldn't use it as a means to implement a back-end server. I would use it.
Of course, that's how you communicate with everything. release or press release.
Oh, I see. No, they're not required. Because, again, at the end of the day, what the view model is actually acting as is kind of like that controller that you see. It's just routing stuff to the services. Really, there shouldn't be any business logic inside of a view model. It's presenter logic. So very clear distinction. Good question. Anybody else? All that pizza, everybody's tired, they're on the move. Why is that keep talking? I know people who have asked me that question at work every day. All right. I should say one more thing. We are big on MVVM process. We are hiring .NET, Web, Salesforce. We'll take you. No, as long as you know something, you can turn on the computer. He's gonna kill me later. All right. Thank you guys. Appreciate it. All right.